quizzes go pretty quick when there's only two of them in here. Yeah, I thought so. Especially if you know how to use the calculator for the DMS. Okay, so coming out of the quiz now, some things that we need to review some more. Lines like that are always the same distance apart are called what? Parallel. A line that cuts across two or more other lines is called transversal. Now, perpendicular has to cut them at right angles.
Oh, okay.
When we have a transversal across parallel lines, this angle here, let's say this angle is 54 degrees. What does this angle here have to be? Yes, it is 54. That is what we refer to as vertical angles. They are formed by intersecting lines. When two lines intersect, all the angles formed are either equal or supplements. So that would imply that this angle, of course, would have to be a supplement, right? 180 minus 54 is going to give us 126 degrees there. So then this one has to also be 126. Those two are also vertical angles, the two 126s. They're formed by the opposite sides of intersecting lines. Down here, if I took this line and I slid it up here, it's going to lie right on top of this other one, right? So this angle here would be that one, 54 degrees. This angle would be 54 degrees. What about this one? 126 and 126. There are all sorts of rules out there for parallel lines cut by a transversal. There's all sorts of names. There's corresponding exterior angles, corresponding interior angles, alternate exterior angles, alternate interior angles, all sorts of names out there. To make it simple, we're just, whenever there's parallel lines cut by a transversal, all the angles formed are either equal or supplements. And it really is that simple. Now remember, when we had a triangle, what do the angles of a triangle have to add up to? 180. So if this one here is 82 degrees, this one is 73 degrees, this one's going to have to be 25 degrees, right? 180 minus 82 minus 73 is 25. So with that in mind, if I tell you that this angle here is 46 degrees and that this angle here is 82 degrees, I want you to find, actually I'm going to number them to make it more consistent. Yeah, 13 usually comes after 12, doesn't it? Find those 18 angles. Let's start out with that 46-degree angle. What other angles here have to be 46 degrees? 2, 15, and 17. Next, let's look at angle 1. What's that have to be? 134. What other angles have to be 134? 3, 16, and 18. Good. Now, did you find any others? 8 has to be what? 98. 82 and 98, of course. Didn't give you enough information for the rest, did I? Doesn't look like it, but I did. What's 4 here have to be? Close. 36. Once that's 36, I know that this has to be 36. Anything else have to be 36? 11 and 13 are both 36. And then the rest of them have to be 144. It's amazing how little information you have to find everything on these. How about that's 111 degrees. This is going to work out horribly, but pretend that looks like a right angle. I know it doesn't look like one, but I should have drew this one horizontally instead of vertically. Find those other 12 angles. So, what other angles have to be 111? Careful. Just 2. One and 3 both have to be 69. 4 would have to be 69. And 7 would have to be 69. Now we know that has to be 111, right? So if I take out 90, that one's 21. Which makes this one 21. Of course, this one's 90, right? If this one's 21, what other one's got to be 21? Of course, that makes this one and this one 159. Not so bad?
I screwed up, but yeah, I see where you're getting your numbers.
Okay. If I have an angle, let's say this angle is 33 degrees, just for fun. I'm going to construct a side parallel to this side. So I'll move it wherever I want to. Construct another side parallel to this side. So again, I'll move it wherever I want to. Come on. What's the angle form there going to be?
33.
What if I move it to here?
33.
So this angle is going to be 33 degrees. Are there any other angles I could possibly form with that? Yeah, of course, right here. 147 degrees. So if I have an established angle and I construct lines parallel to its sides, I'm either creating an angle that's equal to it or supplementary to it, right? Well, how about I do this? I'm going to construct a side perpendicular to that. I'll construct one here perpendicular to that. So now if I move these, if I put that one there, what angle am I going to get here? How about this? Let's make it a little easier. Let's do this. If I leave it like that, what angle am I going to get here? This is 90 and 90 and 33. If there's 4 angles in a figure, the angle sum has to add up to 360. So 360 minus 90 and 90 is 180, minus 33 is 147. It's supplement, right? So that's 147. This angle would have to be 33. So if I have an angle and I create lines perpendicular to the sides of that angle, they'll either intersect at that angle or it's supplement. Does that make sense?
Yeah.
So we have a corner of a house. Let's see, the corner of this house makes an angle to 130 degrees. I construct this line here parallel to this side. This line here parallel to that side. What angle do I get? 50 degrees. Now, more than likely, that angle would be constructed within the house. You might have this parallel to that side and this one parallel to that side. This angle, of course, would be the 50. Or you might have a wall coming off of here and a wall coming off of here at a right angle. What's this angle going to be? 50. Very good. What if I have a wall coming off of here to perpendicular? A right angle here. What's this angle have to be? 50. Why? If these are two right angles, that means this line and this line are parallel. So this angle here would have to equal this angle out here if I extended it. Okay. The concept of a triangle is extremely important in construction because of the idea of rigid frames. Rigid frames are just frames where all you have to do is pin the end and they will stay. If I have a board here, and a board here. If I put a single bolt through here, this is free to swing back and forth, right? I put a board here with a single bolt. That one is free to swing back and forth as well. If I attach a board across here and pin it, one bolt, that stop it from swinging? No, this can still, the whole thing can slide over if it needs to. If I have triangles, however, a single bolt in each joint, will that move? No, it can't. This one tries to swing, it's going to run into this one. This one tries to swing, it's going to run into this one. A triangle is a rigid frame. That's why in construction, we try to create rigid frames, triangles as much as we can. I mean, the obvious one where we use a triangle is a roof truss. Not only is the whole truss a triangle, but we use the webs to create smaller triangles within the truss, like that. All those are triangles. We talked about the attic trusses being slightly unstable because it has a rectangle in the middle of it. So basically that doesn't have any truss strength. It all becomes a beam at that point. But you might have some weird shapes. To stabilize and brace it, we need to create triangles. You need to think about the most efficient way to create those triangles. Like here, I could stabilize it by bracing it here and here. Of course, there are other ways I could have braced it too. Could have braced it like that and that. Everything's now a triangle. Nothing's left as a four-sided figure. That's one of the exercises we're going to look at, is creating those triangles. This is why when you build stud walls, you build those stud walls, you set them up. What's the first thing you do? Put a diagonal brace on them. That's creating triangles here. And even though it's not technically a triangle, this trapezoid works as a triangle because of the way it's set up. You're creating what you're doing is you're creating this triangle, this triangle, this triangle, that triangle, all those triangles on the way up. So a lot of vocabulary and a lot of exercises like that for this second hour today. Page 482 through 484. This is all in the big book as well. Exercise 21-4. And the little book on page 489. Exercise 22-1. Dealing with those rigid frames. So if you want to get those done, we'll give you the last 15 minutes to work on them, and we'll call it a day.